We had a decorating problem.
Hanging your television over the fireplace is what people do. It's a good place to put a TV, and it keeps it up and out of the way while staying in full view from anywhere in the room. Unfortunately, it also puts that same piece of electronic gear on the wall in front of you even when it's not in use. Some people think this is tacky.
Some people buck the TV over the fireplace trend by putting artwork over the fireplace instead of a television, kind of like this. A painting is less technical and better fits the room when the TV is not in use, but then your TV is someplace else and you've got all those cables and wires and everything to worry about, so you haven't really solved your problem. It's a raging debate. TV over the fireplace or art over the fireplace? Which is better? Well, we don't care. We did both. We decided that we wanted to cover the TV when not in use so that the electronics would be completely hidden unless we wanted to use them. Hiding things and putting electronics in odd places is kind of the theme around here. This is what we built. It's been running here for 7 years at the time of this filming, and it still works great. But 7 years ago, we weren't using video to record our builds, so I really just have a bunch of still pictures to show you. But we'll mix it up with some current video, so it'll be interesting. Let's do the walkthrough.
The first step in the project was to put an alcove into the wall over the fireplace to put the television in. We had a blank wall that could not hide a television, but that was okay because we knocked a large hole in that wall. We did reinforce the hole later because we didn't want it to collapse. And we got rid of the sconce wiring you see on the left and right. See that silver thing running through the hole? That's the fireplace vent tube. More on that later. To close the hole, we put a backing on it that we could mount a television on. I hate trying to find studs in walls, don't you? To make stud finding easier in the future, we used 1/2-inch plywood strips for the back. This gives us a stud in the television alcove anywhere we drive a screw. So convenient. In the back of the alcove mount, we mounted a 3-inch PVC pipe that angles down towards the electronics alcove to the left. This allows us to pass cables behind the TV down where we can reach them on the floor. Then we painted it, and we were good to go with our alcove. It looks like a picture just hanging over a fireplace, doesn't it? But this picture, which we refer to as the blast shield, is hanging on an aluminum lift mechanism that lifts the picture out of the way of the television.
Okay, here's how it works. There's an aluminum frame that supports the picture. It comes down and attaches to drawer pulls that are on the left and right. The drawer pulls are mounted to the wall and they're covered with wooden strips to hide them. But it's a drawer pull attached to another drawer pull with the framework overhead and the same thing on the other side. In the center section, there's an aluminum rail and there's a cable that attaches here that goes all the way up through a pulley right here. So it's actually pulling from this position here when it lifts. And the cable goes back into the attic, and we'll go up there and show you that in a second. But this is how the frame works. This is it in action.
The lift mechanism is made of 4 drawer slides. 2 are on the left, 2 are on the right. These are heavy-duty drawer slides that are designed to hold heavy loads without sagging or rising in their mounts. This makes them excellent candidates for vertical applications where they won't rack to the left or the right. We have removed the white wooden cover so that you can see the left drawer slides in action. You see them extend as the lift mount rises, and then fold back up when the lift comes down. The center rail of the lift mechanism conceals a 1/8-inch steel cable that is used to lift the picture frame up the wall. The steel cable goes through the wall at the top of the lift mechanism using a pulley. For our primary lift mechanism pulley, we decided to use something called a sash pulley. Sash pulleys are used in older windows to link counterweights to windows so that the windows are lighter to lift. We like sash pulleys because they lay flush against the surface, which is exactly what we needed for our lift mechanism.
The frame for our artwork is made of a lightweight pine, and the surface is foam board with a layer of canvas glued on top. The frame was stained a dark color to provide contrast with the wall. The artwork we chose to paint involves the Jackrabbit Trading Post sign from the real Jackrabbit Trading Post on Route 66 in Joseph City, Arizona. That's right, we went and got our kicks on Route 66. We even stood on the corner of Winslow, Arizona just because we could, and we have fond memories of those desert road trips. The artwork itself features the famous Jackrabbit Trading Post sign as well as various family inside jokes here and there scattered around the painting. Also, there is a TARDIS on the upper right-hand corner because sci-fi is important to your family's development. When we finished, we had a real painting, even though it's really a shield meant to conceal our television. And on the back of the frame is a metal rail that allows us to hook the picture frame onto the aluminum lift mechanism. All of this is completely hidden by the picture frame structure.
Now, how does all this stuff work? Well, there's a power supply, but it's just a metal box that provides 18 volts of power, so it's not very exciting and we didn't take any pictures of it. For the muscle of this project, we chose what is called a linear actuator. A linear actuator is a giant screw that a motor turns to extend and retract a piston. An actuator gives us the push and pull forces that we need to lift our picture frame. We used the 36-inch gate actuator, which is weatherproof and is used to open and close gates outside, as our lift mechanism. It's really powerful, and it was pretty cheap on eBay. We built a lever to connect to our linear actuator, which we'll show you in just a minute. It's a little difficult to get good light up here in the attic, and I've got the air conditioner running over here, so I hope you can hear me. This is the 36-inch gate actuator that makes the picture frame go up and down. We've got it mounted at an angle here, and here's the piston attached to the lever that pulls the cable. This is the motor back here that makes it go in and out, and the lever turns that force into a pull force that pulls on the cable. But it's all mounted here to the ceiling joists, and it's not going anywhere. And it's out of the way, but it's a big monster, and this is what makes the picture go up and down. You can see the piston connected to the lever here, the body of the actuator, and then the motor way down there at the end. The piston is connected to the lever, and at the end of the lever is a connection to the 1/8 inch cable. It goes through a series of pulleys that go around the vent for the fireplace and then back into the sash pulley. You remember the sash pulley? That's the pulley that takes all this force from the attic and transmits it through the wall to lift and lower the picture frame. Now, how do we control all of this? Well, we have a 3-position toggle switch that reverses the polarity coming from the power supply going to the linear actuator. The linear actuator has limit switches inside, so it will only go so far forward and backward before it shuts itself off. So all we have to do is send it power in the direction we want it to go and let it complete its run, and it automatically stops. We've described the picture, lift mechanism, pulleys, the lever, actuator, toggle switch, but we didn't show you the power supply, but it's there. Now, let's watch it all work together.
Now we have a picture frame that becomes a TV. We want to watch TV, and there's a picture frame at all other times. Because why decide if you should have a fireplace TV or an artwork over your fireplace when you can, in fact, have both?